Lesson 12.7, Circles in the Coordinate Plane. The objectives of the lesson are to write equations and graph circles in the coordinate plane and use the equation and graph of a circle to solve problems. The equation of a circle is based on the distance formula because we are looking for the distance from the center of the circle to the circumference, and that would be the radius. Looking at the graph, we have a circle with center HK, R radius, and we have a point that we've identified on the circle XY. If we use the distance formula to find D, then this time we substitute in our numbers. We have H and K for our X's and Y's, because that's where the center is. And we have R instead of D, because our distance is the radius. If we square both sides, we come up with the formula for a circle. R squared equals X minus H quantity squared plus Y minus K quantity squared. The equation of a circle is the one we just derived, and this is theorem 1171. Let's look at a couple of examples. We'll start with writing the equation of the circle J with center 2, 2, and a radius of 4. First of all, we look at the equation, and then we plug in what we know. The center is HK, so we substitute that in, and we substitute 4 for R squared. So we have X minus 2 squared plus Y minus 2 quantity squared equals 4 squared. We'll simplify by squaring our radius. And this would be the format that we would be looking for the equation of a circle. X minus 2 quantity squared plus Y minus 2 quantity squared equals 16. Let's look at another one. This time we have a point and the center, but we don't have a radius. K is a circle that passes through the point J at 6, 4 and has a center K, which is 1, negative 8. So first of all, let's look at the distance formula, and we plug in the values from our 2 points to find the radius. Simplifying, we see that our radius is 13. We're going to substitute 1 for H, negative 8 for K, and 13 for R. And then we simplify. And you notice we change the sign on this negative 8. Since it's negative of negative 8, we make it plus 8. But we remember that what's in the parentheses, like this, has the opposite sign. And it equals 169. We're going to need to graph circles. So if we are given an equation, we can graph by making a table or by identifying the center and radius. Let's look at an example. Graph the circle x squared plus y squared equals 16. Step 1, we want to make a table of values. Since the radius is the square root of 16, or 4, we're going to use positive and negative 4 and all the values between for x. So we make a chart. We have negative 4, we plug that in, we get 0. We have negative 3 for x, and that gives us plus or minus 2.6. Negative 2 gives us plus or minus 3.5. 0 gives us plus or minus 4. Then we have 2, and we repeat our pattern. Now we have enough points to plot, so we're going to plot the points and connect them to form a circle, like so. Let's look at another example. Graph x minus 3 quantity squared plus y plus 4 quantity squared equals 9. Well, we look at this and we see that the equation is gives us y minus -4. Because this is positive, we know that it used to be negative before we negated it with our negative sign here. And we take the square root of 9 and we get 3. So h is 3, k is -4, and r is 3. The center, 3, -4, and the radius is 3, so we plot the point 3, -4, then graph a circle having the center and a radius of 3, like this. So if I make my point, I can count in any direction 3 and make my little dots and then connect them in as best a circle as I can make. Let's look at an application problem. An amateur radio operator wants to build a radio antenna near his home without using his house as a bracing point. He uses 3 poles to brace the antenna. The poles are to be inserted in the ground at 3 points equidistant from the antenna, located at J44, K, -3, -1, and L, which is 2, -8. What are the coordinates of the base of the antenna? Well, let's break this into steps. First of all, we want to plot the 3 given points. Then we're going to connect to J, K, and L to form a triangle. So we have our 3 points, and we've made a triangle. Step 3, we're going to find a point that is equidistant from the 3 points by constructing the perpendicular bisectors of 2 of the sides of triangle JKL. So we look for the perpendicular bisectors, which means that they bisect each side and are perpendicular to that side. So we would have to find the one that was parallel to this side to be perpendicular and to this one to be perpendicular. And we're looking for the place they cross, which is going to be over here on the hypotenuse. The perpendicular bisectors of the sides of JKL intersect at a point that is equidistant from JK and L. The intersection of the perpendicular bisectors is 3, -2. P is the center of the circle that passes through JK and L. The base of the antenna is at P point 3, -2. So see, we found our perpendicular bisectors, and they intersect here on the triangle, which means that this was a right triangle. We said that perpendicular bisectors will be on the hypotenuse if it's a right triangle. And this is the center. So we count out equidistantly and make our circle around that. Now what if the coordinates of 3 cities are D, 6, 2, E, 5, -5, and F, -2, -4? What would the location of the weather station be if it were at the center of the circle containing all 3 cities? So step 1, we want to plot the 3 given points and then connect them to form a triangle, just like we did in the last problem. So we have our triangle here, and we're going to need to find the perpendicular bisectors of 2 sides so that we can find the point. We're going to construct the perpendicular bisectors of 2 sides of DEF. They intersect at a point that is equidistant from DE and F. And in this case, it is at 2, -1. P is the center of the circle that passes through D, E, and F. The base of the antenna is at 2, -1. And you can see again, we have another right triangle as we have our intersectors on the triangle hypotenuse. Now you try. Write the equation of each circle. And then graph each equation. And 2 more graphing problems for practice.